Welcome back, physics fans. This is Physics 11 projectile package number 18, and this is a special one, so please join with me. The previous couple questions, I think it was on 15, it was explored that, and 16, that if we launched at a weird angle, let's say like that, and you're given the number here, 50, and the angle here is 60 degrees, then you have to calculate what that is, and let's say that's going to be 47, and this is 25, or something like that, okay? That's what we were given last time. We were given the hypotenuse and the angle. But now I'm going to throw in a bit more tougher stuff, but I'm going to keep this for later. We're going to keep that for later. I'm going to give you these just so we don't have to do the sine and cosine to get them to begin with. Let's just focus on what does this all mean once we have an initial vertical velocity of 0. They're not horizontally launched anymore. They're not horizontally launched. Uh-oh. Most of the questions that we've done before, like questions 1 through 13, were all horizontally launched. What does that mean? Well, it means this. No, you cannot use this formula anymore. Well, let's just read this question and we understand why. A boy throws the rock up and out from the top of a 20-meter high cliff. The horizontal speed is 25 and the vertical speed is 47. So you put those in here, and I've done that. I've done 25 horizontal and vertical 47. I put up because that's important. And now the acceleration is 9.8 down, and that is 20 down because it's a 20-meter high cliff, so that's where it starts from, as the top, and it goes back down. But this is not 0, so we cannot use this. Cannot use that to calculate the time. So this is a loaf of bread question if you've been in my class. We can calculate that, but we need the quadratic formula to calculate that. So the first thing you do is calculate this instead. And that would be VF squared is equal to VI squared plus 2AD. So VF squared is going to equal 47 squared plus 2 times 9.8 times 20. Now please, when we did the loaf of bread, the biggest tripping hazard is the signs. These arrows are the signs. We choose which one is negative, which one's positive. We get the same answer afterwards. I want the downward to be positive because when it lands, it's going to be going down. So I want that to be positive. So that will be negative. It doesn't matter. If both of these were negative, it would still be positive over here. So negative 47 squared. Calculator, here we go. 47 squared is 2209. It'll be positive, plus 2 times 20 times 9.8, 392. And then we add that number above, and we get 2601 is VF squared. And now we have to square root it. It's 51. And we know we're going to choose the downward one. Calculated. What's the final velocity? Oh, okay, now it's launched at 25 this way, and it lands at 51 this way. So Pythagoras and inverse tan. So the square root of 25 squared plus 51 squared, and then we also have to do the inverse tan of 51 over 25. So let's do them. The square root of 25 squared plus 51 squared, and the inverse tan of 51 divided by 25. There we go. So the vector final velocity is 56.797, let's go 80 meters per second at an angle of 63.89 degrees, and that'll be below the horizontal. And now C, how many seconds did it take before it hits the ground? So it launched upward at 47 and it landed downward at 51. So the change in velocity is not 4. "47 this way and 51 this way, what's the difference between them? That's going to be 98. So the time is the change in velocity over the acceleration, and that's going to be 98 all over 9.8, which is equal to 10 seconds. And how far from the base of the cliff? So it's now, we're launching, and we want to know how far that is. The time of the flight times the horizontal speed. The time of the flight is 10 seconds, and therefore d will be velocity times time. 25 times 10 is 250 meters. There's my answers. So the thing here to fall and not fall into the trap is that we can't use that square root of 2d over a because that's not horizontal. So once it becomes that, then most likely it's a loaf of bread question. So we have to solve for the velocity first. And it's useful because then we can get the final velocity. Not just the final vertical velocity, but the final total velocity. But then we can get the time and the range. So it's just a loaf of bread question thrown into a projectile. It's pretty good. After 18, though, we have question 19. And this is the exact same thing that we just did, except we now use 12 for the acceleration. So practice that out. I probably won't put that up in a video. And then 20. This is a good one, a projectile, and I'm analyzing two parts of it. So, and it lands at the same height. So it's a projectile that goes, and it lands at the same height that it was land. And we studied up there. How long did it take to get up there? And what's the maximum height? And then afterwards, we look at the whole flight. And we want to know how far did it go, assuming a level surface, and the time for the full flight. And you have to use a Mr. Curlism. What goes up comes down at the same speed. So it launched upward with 49, and it landed downward at 49. Notice I'm doing the tables here from launch to landing, and this is launch to the top of the flight, because it's a different part of the question that it's asking for. The change in velocity here is not 0, but 98. Anyhow, I'll let you do number 20. That's 19 and 20. And the answers for 21 and 22 are up online, so we're smoking through this package. And this is a 22.3 is a level ground one, and you have to do the whole thing. It's wonderful. You can do it. And this one is, ooh, yeah, I'll be doing 24. Anyhow, thanks for paying attention and enjoying the projectiles, I hope. And good luck. Have fun. See you later.